Our next video continues our talk about functions. The next thing we're going to talk about is the rate of change. Now notice I did call it easy mode rate of change. We will learn more about rate of change as the year progresses, particularly after MSA. On your paper, there's a space where you need to record this circle map. If you would like, if you would like to play it first, and then you can rewind it and then record it, or you can pause as you go. I just wanted to make sure you knew that option before I started going through them. First of all, rate of change for now is only going to apply to linear functions. Remember, linear in our last video meant a straight line. Another word for rate of change is called slope, which is represented by the variable m. In Algebra 1 and in 8th grade, slope will become a very, very big deal. For now, instead of using the formal slope formula, we're going to decide if rates of change are decreasing or increasing. We'll get more specific later on. And finally, you can see rate of change in a table, in a graph, and in an expression. At this point in math, we're going to be looking at it in a table. A graph is probably the easiest way to look at this, but the table is where we're going to begin for right now. Again, if you need to pause to write this down, please do so. Instead of creating brand new questions, we're going to go back to the problems we used yesterday in the graphing lesson. And we're going to talk about how you can tell if it's increasing or decreasing. Our first problem from yesterday had the formula, function rule, 2w. And here was the table we came up with. And we need to decide, is it increasing or decreasing? My cartoon bubble is a little bit off the screen, but that's what's right here. There is a place on your note page where you need to record this information. A table shows an increasing rate if the inputs and outputs are moving in the same direction. If you were to look at this graph that's increasing, on a graph, it would be moving up from left to right. So that's what increasing means. Decreasing rate happens if inputs and outputs are moving in opposite directions. If we were looking at that on a graph, it would be decreasing or moving downhill from left to right. Looking at our table, our inputs are counting up, 1, 2, 3, and our outputs are counting up, 2, 4, 6. So that means that this rate is increasing because they're going in the same direction. Now be careful. Notice how I define increasing. It's not increasing because the numbers are increasing. It's increasing because the inputs and the outputs are moving in the same direction. You'll see an example later where they're not all increasing, but they are moving in the same direction. The second example that we had yesterday was this one. If I look at my inputs, they are increasing, but my outputs are decreasing. I'm counting down, 8, 6, 4. Because the inputs and the outputs are going in opposite directions, this is decreasing. If you remember from yesterday, this graph was moving downhill. You can look back at your notes if you want to see how this looks in graph form. For a quick check, or your turn, I have two tables on your page. Now first of all, I want you to notice they do look different. Instead of being two vertical columns, this has two horizontal rows, but things are still the same. The inputs are the top row, the outputs are the bottom row. I'm going to watch the timer on my camera, and in 10 seconds I'm going to go over the answers. So please pause the video and give these a try. In the first example, the inputs are counting down, 5, 4, 3, 2. The outputs, however, are counting up, 12, 19, 26, 33. They're going in opposite directions, which means this table is decreasing because it's in opposite directions. Take a look at the second table. Remember, I forewarned you about this one. The inputs are counting down, 11, 9, 7, 5, and the outputs are also counting down, 12, 10, 8, 6. Just because the numbers are counting down does not mean this is decreasing. In fact, if you don't believe me, on graph paper, feel free to graph this. You'll notice that it's actually increasing because the inputs and the outputs are moving in the same direction.